Hello, everyone. So we'll get started with this presentation. Our speaker is Mr. Miguel. He'll be speaking on the topic, the role of AI in the space industry and Mars. So shall we go ahead, Mr. Miguel?
Yes, thank you very much. So hello, everyone. My name is Miguel Peláez, and I live in Madrid, in Spain. So actually, right now it's 12:30. So it's midnight. And in this session, I will be talking about the role of artificial intelligence in the space industry and the Mars exploration. Just a brief mention about my background. I own a PhD in physical complex systems, and my last 10 years of work experience, I have been working on the application of artificial intelligence in multiple business industries, from manufacturing, digital marketing, staffing, energy, logistics, but not in the space industry though. First, I would like to thank to the organization of the Mars Society to accepting my humble contribution to this online convention. My interest in astrophysics and cosmology naturally set me my interest on the space exploration, which brought me to the Mars Society conference. And I thought, based on my professional experience, that it could be interesting to think over artificial intelligence in such context. So here it is, my contribution, as I mentioned. Okay, so let's start talking about artificial intelligence on Earth. I like to consider this discipline from three different perspectives. So from the historical point of view, in the past, we have a few examples of the human desire to emulate itself through the construction of smart machines. But it was not until the development of computers that we could explore algorithms in a broad spectrum of shapes and flavors. Something that we could say began on a conference in 1956, and it has been growing interest until today since then. To simplify, there are two approaches to simulate the human behavior through algorithms. A deductive and an inductive approach. The deductive approach consists on building algorithms based on mathematical entities that mimic our understanding of human behavior. This is highly connected with our understanding of psychology, so how the human mind works. So for a long time, this was the main approach in the artificial intelligence discipline, because it was based on our ability to model how our brain processes information and react to different stimulus. The fact is that we still don't have a successful model to explain how the human brain works. So we are far, actually, but it requires much work. And the brain is a set of interconnected neurons that shoot electric pulses in an apparently random way. So as far as we know, our conscience and so our human-like behavior emerge from that psychological activity. And given the number of neurons and interconnection between neurons, today we have limitations to solve it. So nevertheless, all the work that has been done since 1956 to the 2000s is valuable, but from a business perspective, which, you know, pushes everything, I mean, business work, there was not a suitable environment to implement these tools at a scale. So it was not until the last 10, 20 years where artificial intelligence emerges as a great tool for business, and so it is when people started to pay attention at a global scale. This fact comes together with an inductive approach, not a deductive, to the artificial intelligence. So the inductive approach consists on the development of algorithms that are able to learn from data, okay? And, you know, we are living the digitalization age. In the industry, this type of data to teach the algorithms are called training example. So the different respect to the deductive approach is that we are not modeling the behavior. So the behavior is somehow embedded in the training samples. And these type of algorithms are able to identify the patterns just by one simple criteria, which is minimize the error in the training phase. So with this simple but powerful idea, and of course, with the ability to gather large amount of data, as I mentioned, we have been able to develop algorithms that can tackle human tasks with an accuracy as good as human or even better than human for some specific problems. So here is the inflection point in something that we call narrow artificial intelligence. It is narrow because it is just possible to solve a specific task. So we are not yet, and actually we are far from in the position to say that we cross the inflection point for the general artificial intelligence, where an artificial system is able to perform better than humans in complex tasks, consisting, on multiple decisions and actions. But perhaps we will see that in the next decade. But anyway, the fact is that this approach has brought multiple industrial applications and so a lot of interest from multiple point of views. Although we have already mentioned one of the point of views, the historical one, let's now focus on the other two. So one is the economic point of view. To simplify, if we can find a task in the corporate world that one in a daily basis require 1 or 2 seconds of a human to do, which means it is a simple task. And 2, we are able to digitalize the data that a human will require to run the task, which in other words, we call it input data. Then we are in the position to train one of these algorithms, which with enough amount of data to substitute the human on that specific task. This way of thought is the way of thought of efficiency. And in the corporate world, being efficient means being able to be more competitive with respect to others, okay? So this is the main reason why this technology, the artificial intelligence, the narrow artificial intelligence becomes quite important to the corporate world and of course to the economy. As a consequence, more researchers are attracted to these disciplines on the academic world, more money is invested, and in a feedback loop, more and better artificial intelligence tools reach to our economy. So you can find use cases, examples in any industry and at multiple areas on the same industry. For example, in energy, so you have algorithms to predict the energy demand and optimize the use of the plant an energy plant ecosystem. Algorithms to predict when a plant of an element or an element of the plant is going to fail, so the artificial intelligence helps on preventing these unexpected failures. For example, in retail, in store algorithms to track customers in store throughout the cameras and see what user demographic interact with more to with the products to improve the experience, or algorithms to predict what is the best stock price for a product based on the demand. In transportation, we are able now to autonomous drive, optimize for routes based on business criteria. In healthcare, we are talking about personalized healthcare by understanding large amount of biological data for a specific patient, or help a doctor with processing large amount of, for example, X-ray inspection data to detect with the same accuracy an illness. In finance, in education, in manufacturing, like for example, for quality assurance in an online processing during the production process, through automatic visual inspection, predictive maintenance, again, for the production machine, in agriculture, in social media, in marketplaces. So, and I just gave you, a few examples per industry, but I will stay here for like 10 or 20 minutes giving you examples based on, my humble experience in the different industries where the artificial intelligence is playing a role. Okay, so this is just from the point of view of the economy. I talk about the historical point of view, the economic point of view of the artificial intelligence. Let me talk briefly about the philosophical implications of artificial intelligence, okay, on Earth. So let's talk now about that. So we are experiencing an exponential growth, as I mentioned or tried to illustrate before with my examples, on the research and economic development of artificial intelligence. It is true that there are regions with faster growth than others. For example, there is no doubt that the US and China are leading this growth. And for example, Europe, where I'm living now, is getting a delay on that sense. One of the reasons is, for example, a cultural one here. So Europe is a region where the human is in the center, like an Hellenistic point of view of humans, and every technology that can create a revolution goes through a large friction with the standard way of living. So artificial intelligence is going to create a social class, like in other industrial revolution did. Just consider all the repetitive work that humans have been doing for years. Computer can now do it faster, for longer times, and sometimes even better, as I mentioned. So those people will be displaced from their current duties, and what will they do? So it is not clear to me, and I guess not to too many people. It is true that such work displacement will not be radical, like we see it. I see it. Most of the human-only tasks now are human-in-the-loop tasks, which means that artificial intelligence is doing the heavy duty, but there is a supervision of a person at least, or a couple of people on the work that the artificial intelligence is doing. So if the task is included in a job that didn't exist before, I mean the human-in-the-loop task, so then we are talking about job creation and not destruction. For example, jobs consisting on social media content supervision or data tagging centers. So those are works that didn't exist before, but the balance seems to be negative, and the cost for training is always a stopper. So it will be also, there is also a barrier for that from that point of view. So again, this technology brings us a clear social impact, and we will have to deal with a period to process these changes at a social, an economic, and a political point of view or level. And in addition to that, probably we will have to do it in a rush, because as in the past, these changes take a long time. But in the technology war, in this case, with this technology, we are seeing that it evolves very quickly. So every year there is like a new trend that improves what we have seen before. So there is another implication. If we don't have the work machine does, we will have more time to do what? That is the other implication. What is the key question? What is so what I mean is perhaps we will be able to do more things that only humans can do, because the repetitive tasks can be performed by machines. So from this point of view, we are excluding human from our comfort zones. But if we are optimistic, we are pushing to do extraordinary things that only humans can do, like, for example, traveling to Mars. In that sense, and hopefully we as human civilization can collaborate to move on that sense, we need to design a humanity 2.0 in the Earth, not in Mars, that is able to handle without chaos, more free time. So if we can do it for a good purpose, like, I mean, progress in our civilization, it will be a 2.0. But if we fail on that purpose, then we will be talking about something quite like the Matrix or Blade Runner type of movies. So as we mentioned before, we are getting closer to the inflection point, the singularity, where we can create an artificial general intelligence that is by itself another disruption to humanity, since we are in the position to claim we are gods. In most of the religion, gods are responsible for the human creation, and we will be creating machines that behave in a general perspective like humans. So we will interact with them in the same way as we do between us. But regardless, the minimum differences between an artificial general intelligence and a human-like intelligence, there are two main differences. So they don't die, and they can be better than us, I mean smarter. That can be a risky scenario we should be prepared for as well if we reach to the singularity point. So, say that, let me now talk about the role of the artificial intelligence in the space industry, the space industry development. Okay, I'm sure you have been able to imagine the role of the artificial intelligence in our future space exploration and Mars colonization while I was talking about artificial intelligence from different point of view, but let's talk about that in detail. So artificial intelligence will speed up the space industry as in other industries I mentioned it before. In the space, we have a large dependence on computers, computer process data, and the data can be interpreted by artificial intelligence for an automatic decision making, right? In fact, the space industry standards were created in the past under the criteria of having the spaceships controlled mainly from an Earth-based monitoring system. But this is an obvious assumption, right? There are many more things we are doing in the space right now, or we expect to do that will require the help of artificial intelligence to move forward in our exploration in a more efficient way. For example, space debris monitoring and mitigation using artificial intelligence algorithms with the data of the monitoring that we have, new planets discovery using artificial intelligence on the telescope images, autonomous robotic operation in microgravity conditions, smart energy use for long trips based on all the sensing parts of the spaceships and all the energetic contribution from different sources, autonomous planetary landing for sure will be one of them too, spacecraft anomaly detection, to prevent failures that could be painful and even to destroy the missions, terrain-aware autonomous driving on Mars or other planets. That is also another important thing, as we are doing in the Earth, personalized health monitoring for astronauts, precision agriculture on planets or in a spacecraft to improve the amount of food that we can grow based on all the parameters that we can measure and that are relevant for the growth of plants. And of course, the last but not the least, and the one that I wanted to focus now, is the artificial intelligence as a companion. Here I want to stop for a while and talk about this topic. So, artificial intelligence as an exploration partner. We are looking at the future, but many times when we do a step forward, we rely on our previous experience in order to learn what can we expect. What should we prepare in advance, even if we don't know the environment we are going to? In other words, what others did in the past in similar circumstances, and how did they handle for success? So the fact is that even if we, the human species, haven't been in Mars yet, we know what it looks like going from point A to point B without knowing about point B for the first time. And we know what it is look like to rely on technology on such adventure. I can give you a clear example, as you can see here in the picture. 500 years ago, we crossed the Atlantic Ocean in a ship that today will likely disappear. We rely on the technology improvements on that age, together with our knowledge on astronomy for navigation to guide the ship, weather forecasting, and so on. This was purely scientific knowledge taking form of technology and sharing with us, that is the important point, as an artificial partner, the painful event to colonize a new world. Of course, we don't expect to find some life as we found in the Americas discovery, this example, but still there are analogies. And that's why I wanted to leave here. So what is the role of artificial intelligence in this adventure? Space, Mars exploration. We talk about artificial intelligence as a technological tool, but we also have to consider the companion, our partner in this endeavor. As the artificial intelligence evolves to a more general thing, we will be able to interact as we do with other humans. If we think on the timing for the first human in Mars and the timing for the singularity in the artificial intelligence, it is clear that both are going to happen at some point in the next 10 to 20 years, even earlier. This means that we can expect to travel along interplanetary distances, having a human-like companion that can take control over the spacecraft, can predict issues, can help with operation, and in addition to that, can help us to deal with the loneliness, distant to Earth, memories, humanistic reflection, and so on. In fact, we can find in the historical literature great adventurers giving honors to their ships, to their technological partners. In particular, as we humans do with our babies, at least in some religions, the Columbus expedition, celebrated the baptized with a name, the three ships that they used for this endeavor. The baptized was led by a priest, and you know that the priest blessed the ships to improve the chances that their God protect them, but also blessing is also a symbolic and an act to humanize a thing. Okay.
Oh, so you have 5 minutes left.
Okay, I'm almost done. So the Columbus Daily, you can find mentions to the ship. We can see that they were talking with the baptized ship in a way that provides support, confidence to deal with the unknown. Anyway, this is just an example, and it is something that nowadays we even do when we build an algorithm that has some special mission. So it is a fact we won't be traveling alone to Mars in that sense. But we will need to develop these human-like capabilities. So we will have to teach artificial intelligence emotions, common sense, what is a conflict and how to resolve it, what is to feel pain, self-control, what is the implication of having a trade, many things. I could be listing more and more human-like behavior until the end of the session, and I won't finish 1% of the list about what as human can do. Today, we feel close to understand how the brain works, and not because we are almost there. It is because we are speeding up our discovery process. That is, the hypothesis to say that in 10 to 20 years, we will be crossing the boundaries for the singularity. And of course, if we go to the outer space, we will also have to transform our idea of traveling to Mars or any other place under the assumption we won't be alone. So let's focus on what connects us and to reach our civilization goal. And thank you very much for your patience, and I can handle, I guess, a few questions.
Okay. So yeah, the first question I have is, will AI be better in pioneering Mars or in settlement?
Wow, that's a great question. I think will be for Can you repeat it for Pioneer?
Oh, yeah. Will AI be better in pioneering Mars or in settlement?
I think for in pioneering, okay, not in settlement. I think. Well, I don't know. You catch me. I didn't think about that. Maybe in a settlement, because when you talk about a settlement, you are talking about something that is kind of, moving to a standard way of living. And from our experience, AI is more suitable for in standard environments than in unique and new environments. But that's an incredible question. So actually, I'm super happy to have that question because I didn't think about it.
Okay, another question is, what about Earth-guided AI to build a Mars base?
Can you repeat it again?
What about Earth-guided AI to build a Mars base?
A space.
Oh, a base on Mars, yeah.
Okay, based on Mars. Yeah, I'm pretty sure that, we could train based on the information that we have about the Earth settlements from the historical point of view, and even nowadays can help us to find, where are the geological places that are more suitable for to establish a base in Mars, and so on. So actually, I think I will not be surprised if there is any project already using a satellite image over Mars to identify the different regions based on that information, the satellite imagery, to identify, places for different purposes. Okay, we are doing that in the Earth. Actually, I'm working in a project to find a query to explore the for minery from satellite imagery. But yeah, that will be something cool. And actually, also, providing even more information, not from satellite, but as soon as we get there, we will have so the problem is that we will have to sense different, or have digital information from the surface, not from the satellite. And in order to do that, you need to set up sensors or autonomous machines that will explore the place as we have already, but at a different scale, to provide more information in order to have the data to input the artificial intelligence in order to have some output in that sense. Okay, but we will see. It is, I guess, to me, super hard to think about these things, because I need to start building on top of the data that we have, and right now we have a scarcity on that sense. So that will be my answer.
Okay, and we're out of time now for this session. So yeah, thank you for coming here and presenting.
Yeah, thank you very much to everybody. Bye-bye.